Hello everyone, myself Dr. Ranjith Kumar Gatla, working as an associate professor in the Department of Electrical and Electronics Engineering. So in today's, we are going to continue the numerical problems on interrelation of the two-port parameters. So in the previous classes, we have discussed the various numerical problems on the various two-port network parameters like Z parameters, Y parameters, ABCD parameters and H parameters. So in today's class, we are going to discuss some numerical problems on the interrelation of these two-port networks. So which means, suppose if they give the Z parameters, then how we can find the Y parameters from that? And similarly, so if they give the H parameters, and how we can find the ABCD parameters? So like that. So if we know, because this topic we have already discussed, how to find the interrelation between the various two-port network parameters. So in this class, we are going to solve some numerical problems based on the interrelation of the two-port network parameters. So before going to take the problems, so here, so let us just remind our and our revision. So what are the interrelations between the various two-port network parameters? So here basically we have discussed four different types of two-port network parameters. So the Z parameters, which is nothing but the impedance parameters, and Y parameters are nothing but the admittance parameters. And here the T means, the transmission parameters, we can also call it as ABCD parameters, and finally the hybrid parameters. So here this table indicates the interrelation between the various two-port network parameters that we have discussed. So which means here, suppose if they have given the Z parameters, then find Z parameters. Of course, Z to Z is okay. So from the Y parameters, then how we can find the Z parameters, right? So which means the Z parameters are nothing but here Y222 by delta Y minus Y12 by delta Y. So which means here the transpose of this Z, okay, so which is nothing but the transpose of this Y, sorry, not transpose actually, exactly, okay. So here the inverse, okay, the inversion of this Y, okay, is nothing but the Z, right? So because as we know, the Z is equal to 1 by Y, so that's why here the Y to the power of minus 1 is nothing but the Z parameters. The similar way, if we know the transmission line parameters, then we can also find the Z parameters by using this matrix. And the similar way from the H parameters also we can find the Z parameters by using this matrix. Then similarly, the Y parameters also we can find from the Z parameters, and as well as the ABCD parameters and the H parameters. And the similar way, the transmission parameters also we can find by using the Z parameters as well as Y parameters as well as the H parameters. And the same way, the H parameters also we can find from the Z parameters, Y parameters and the ABCD parameters, right? So this matrix or this tabular column is very important to find or to know the relation between the various two-port network parameters. So based on this table or based on this relation, now we are going to discuss some numerical problems. So let me go with the first problem. So here the first problem is about determine the Y parameters for a two-port network if the Z parameters are given below. So Z equal to 10, 5, 1, 5 and 9. So which means here this is the Z parameter matrix. So here as we know already the Z parameters are Z11 and Z12 and Z21, so Z22. Right? So these are the Z parameter matrix. So which means here Z11 is equal to, let me write here. So which is Z11 which is equal to 10 and Z21 which is equal to 5 and Z12 which is equal to 5 and similarly Z22 which is equal to 9. Now by using this Z matrix, okay, or Z parameters, now we are going to find the Y parameters, right? So Y parameters. As we know already, the Y parameters in terms of Z here, right? Yeah. So the y parameters in terms of z, because here this is the what is that matrix that we are going to use here, right? So z22 by delta z, okay, minus z12 by delta z, and minus z21 by delta z, and z11. So which means here, let me write here, y is equal to in terms of z, so z22 by delta z, okay, and here minus z12 by delta z, okay, and then here minus z21 by delta z, and here z11 by delta z. So this is the relation, okay, for the y parameters, right? So which means here, this is you just compare with what is that, y11 and y12, so y21 and y22, right? So which means here y11, which is equal to z22 by delta z. Similarly, y12, which is equal to minus z12 by delta z. And the similar way, if you compare these two, so here y21, which is equal to minus z21 by delta z. And similar way here, the y22, which is equal to z11 by, here it is delta z. Then substitute all these values. You know what is z11, which is 10. So first of all, we should find the delta z value. So here let me write here delta z, right? So here the delta z is equal to 10 into 9 minus 5 into 5, right? So which is equal to 65. Then substitute here. So y11, which is equal to z22 here. What is z22? 9. 9 by 65. And similarly here y12 is equal to, what is z11 here? Z12 is 5. 5 by 65. Okay, of course, anyway here it is minus. Then similar way here y21, which is equal to minus z21, again 5 by 65 minus 5 by 65. Then y22 is equal to z11, here it is 10 by 65. These are the values of y11, y12, and y21 and y22. Then finally here the impedance matrix, which is equal to, so here it is 9 by 65 and minus 5 by 65, and again minus 5 by 65 and 10 by 65. So this is the impedance matrix, the admittance matrix of y. So this is the way to find the given parameters by using some other parameters. So how we calculate it? By using the interrelation between the z and y parameters, right? So in this way, you can find any parameters from any given parameters, because we know all the relations like z2y, y2z, z2 abcd, and z2 h parameters, okay, and vice versa. So we are having all the relations between the various two-port network parameters. So that's why I told you this is very important. What is the table? So from this table we can find any two-port network parameters, or we can write the relation between any of the two-port network parameters. Right? Then similarly, let us consider another example. So here they have given the hybrid parameters, right? So from these hybrid parameters, we are going to find the y parameters, right? Then how? Now we need to know the relation between the y and h parameters. So which means y parameters in terms of h parameters. Again, let us look at this particular diagram. So y parameters in terms of h parameters. So which is 1 by h11 and minus h22 by h11 and h21 by h11 and delta h by h11. So this is the matrix. So first let us write this matrix. Okay. So which means here let me write here y11 and y21 and y11 and y12. y11 and y12. And similarly here y21 and y22. This is the matrix, that the admittance matrix, which is equal in terms of h parameters. So here it is y11 is equal to 1 by h11, and similarly y12 is equal to minus h22 by h11, and y21 is equal to h21 by h11, and here it is delta h by h11. Now substitute the values. Okay, so here which means y11 which is equal to 1 by h11, which is equal to in here, okay, from this equation you know, right, h11 is equal to 5, and similarly h12 is equal to 2, and h21 is equal to 3, and h22 is equal to 6. Then substitute here the values. 1 by h11, so 1 by 5. Then y12 which is equal to minus h22 by h11. So here h22 here it is 6, by here h11 here it is 5. Okay, so anyway minus 6 by 5. Then similarly here y21, so y21 is equal to h21 by h11, right? So what is h21 here? H21 is equal to 3 by h11 is equal to 5. Then similarly here y22, so y22 is equal to delta h, so delta h here it is 5 into 6 minus 3 into, sorry, 5 into 6 minus 3 into 2, right? So this is 24, right, because 30 minus 6, 24. So then here it is 24 by h11, again here it is 5. Now just write, substitute the values here, then you will get the matrix or the y parameters are. So y11 is 1 by 5, and y12 is equal to minus 6 by 5, and y21 is equal to 3 by 5, right? And here y22 is equal to 24 by 5. So now this is the admittance matrix, which is represented by y. See, here very simple, we just use the relation between the various two-port networks. Then from that relation we are just calculate the various the admittance parameters from the h parameters, right? Okay, so let me see another problem. So you may get like this also, because first by using this particular circuit we have to find one kind of two-port network parameters, and again by using again the interrelation between the two-port networks, then we will find another set of two-port network parameters, right? Okay, so first let me read the problem. So here the network of the figure below contains both a dependent current source and a dependent voltage source. Of course here this is the dependent current source, and this is the dependent voltage source. Determine the y and z parameters. Okay, so we need to find y and z parameters. So which means by using this network, first we will find one set of two parameters, either it will be y or z. Then again by using the interrelation between the two-port networks, then we will find the another set of two-port network parameters, right? So for that, here what I'm going to do here is just I'm trying to write the the nodal equations. Okay, so at point A and point B, right? So if you apply that point A, then the current here it is entering, and here it is leaving, and here it is leaving. Okay, of course here also it is entering, because the direction is this way. Here also it is entering. So then, as we know, the algebraic sum of the currents at a particular node is equal to 0. So first we are trying to find the IAB. Okay, so here IAB, which is equal to because here the entering current here it is I2. Which means suppose if you apply here I2, and I2 is opposite direction, but here IAB we are considering opposite to the I2. So that's why let me indicate with minus, then minus I2 minus the current flowing through this 2 ohms resistor, which is nothing but V2 by 2. So this is IAB, right? So now we are apply node equations at A. Apply the node equations at A. Then here, which is nothing but the current I1, this is entering I1, which is equal. So here, of course, this node is same. So here it is V1 by 1, which is nothing but the V1. Because this is again what is that entering. So I mean, because actually it should be the opposite, so that's why it is opposing. So then we can write here it is 2V2 in this current, okay, and minus, okay. So here IAB, okay. So here IAB is nothing but, because we need to add all these things. So IAB just now we have calculated, which is I2 minus V2 by 2. Right. So let us consider this is one equation. Then the similar way, we are going to apply the node equation at B. Then if you apply the node equation at B, then the equation will become V1 is equal to V2 minus, again here it is 2V1, okay, because here it is 2V1 is there. So V2 minus, here it is 2V1, because the current flowing through this particular, what is that thing, IAB. So minus, again here I2 minus V2 by 2. Okay. So then let us consider here it is equation number 1 and here it is equation number 2. Then simplify equation 1 and 2. Simplify the equation 1 and 2. Then you will get the equation 1 as I1 plus I2, which is equal to V1 minus 3 by 2 into V2. Okay, because here I am trying to write the equation I1, I mean currents are one side and voltages are another side. Then similarly here I2 is equal to minus 3V1 plus 3 by 2 into V2. So from the, if you simplify 1 and 2 equations, or if you rewrite the equation 1 and 2, then you will get the equations are like this. Then if you write these equations in the matrix form, so of course here the left hand side I1 and I2 is there, and here I1 term is 0. So that's why then here the left hand side 2 by 2 matrix, that you will get 1 and 1, okay, and here I1 term, there is no I1 term, so that's why 0 and 1, right. Then similarly the V1 V2 coefficients, okay, so here it is 1, the V1 coefficient, and here it is minus 3 by 2, and here it is minus 3, and here it is 3 by 2 into V1 V2, right. So now here what, yes, yeah, I forget to write here I1 and I2. So we know that what is that, for the y parameters, the equation here it is I1 I2, which is equal to y11 y12 into y21 or y22 into v1 v2. So this is the standard equation for the y parameters. Then I am just trying to rearrange this particular equation into the standard equation. So for that, here I am just sending this one to this side, right. Then what it will become here, I1 I2, which is equal to, already here 1 and minus 3 by 2, minus 3 and 3 by 2 is there. Then you have to just multiply the inverse of this particular matrix, 1 1 and 0 1, here inverse, into V1 V2. If you multiply these two matrix, okay, then finally you will get here it is 4 minus 3 and minus 3 and 3 by 2. So this is the equation that you will get when you multiply these two matrices I1 and I2. So here I1 I2, which is equal to here V1 and V2. Then you just compare this one and this one, right. Then you will get here y, the admittance parameters, which are 4 minus 3 and minus 3 and 3 by 2, right. So this is the admittance matrix, y parameters. So again, now from the y parameters we need to find the z parameters. So as we know already, because in this matrix just now we have seen, so y parameters in terms of z parameters, so which is z parameters in terms of y parameters, right. Okay, z parameters in terms of y parameters. This is also same, okay, y22 and y11, just interchange and put the negative sign, that is fine. So here then the z is equal to y22 by delta y, and here minus y12 by delta y, and here minus y21 by delta y, okay, and here z, no, sorry, y, so y11 by delta y. So this is the z equation, right? So you just substitute all these the y parameters in this equation, then you will get the z parameters. So finally the z parameters that you will get here, it is the z parameters which are equal to minus 0.5, and this is 1, and this is 1, and this is minus 4 by 3. This is the z parameter. So now we have calculated these y parameters as well as the z parameters. See how simple it is. Of course, we are using the same techniques again, whatever the techniques that we are used in the previous problems. Okay, but just some little change. Okay, but that is the key point here. Okay, if you understand the key point, then it is very easy. Otherwise, you may feel difficult. Okay, so this is the way to find. First we need to find either y or z. Okay, so here there is no the compulsory rule like first we have to find the y parameters, then after z. Okay, as your wish. First you can find the z parameters, then we can go for the y parameters by using the interrelation between the two-port network, or interrelation between the z and y parameters. Fine. Okay. Then let me go with another problem. This is another kind of problem. Okay, so this problem is very interesting. As you can see here, complete the table given as part of the figure, and also find the values of the for y parameters, right? So which means here they have given, because as we know for y parameters the current equation in terms of voltage, and similarly the z parameters the voltage equation in terms of current, right? So by using these two equations, so we need to find these missing parameters, because as you can see in the first and second line, of course all the parameters are there. So which means by using this given data we can find y parameters as well as the z parameters. And but in the third, fourth, fifth row, if you see, so there are some values are missing, because in the third row the current values I1, I2 are missing, and in the fourth row the voltage values V1, V2 are missing, and similarly in the fifth row also the voltages V1, V2 are missing. So we have to find these missing values by using the given table, right? So first of all, because anyway here they have given the hint like by using the values of the y parameters. So for the y parameters, let me write the equation here. Just now we have written I1, I2, which is equal to here y11 and y12. Similarly, y21, y22 into v1 and v2, right? So just to substitute the values here. Okay, so anyway for I1 here, let us consider the first two rows. In the first two rows, the I1 having the two values, and I2 also having the two values, and similarly V1, V2 also having the two values. So for that here, what I am going to do here, because to find the y parameters, I1. So here the first case -1 and 27, and not 27. So here -1 and 7, and again in the second set here it is 27 and 24. Okay, so 27 and 24, which is equal to y11 and y12 and y21 y22 into, similarly the voltage also here it is 50 and 100, and similarly 100 and 50. So from this equation, if you want to find these y11, y12, this one, so just send this one to the left hand side, right? Then here this equation will become y11 and y12, y21, y22, which is equal to, Here the same matrix, this I matrix, minus 1, 7, 27 and 24 into this one we have sent to the left hand side so that it will become an inverse. So then we can write 50, 100 and 100 and 50 of inverse. If you multiply these two equations, then finally what is the value that we can get here is 0.1 and here y12 that we can get here it is minus 0.06 and similarly y21 here it is 0.14 and here y22 is equal to 0.2, right? So this is the y parameters, right? Then first is find the y parameters. Then now we are going to find the missing values in the third, fourth and fifth row, right? So now we know we got the y parameters. Then first for row 3, let us find for row 3. So for the row 3, of course here we don't have I1 and I2 values. So let me write I1 and I2, which is equal. Anyway, just now we have calculated the the y parameters. So which is 0.1 and here it is minus 0.06 and here it is 0.14 and here it is 0.2 into here V1, V2 values are there. So 200 and 0. So if you multiply these two, then you will get the missing values I1 and I2. So if you multiply these two, then you will get the missing values I1 and I2 are 20 and 28. So which means here it is 20 and here it is 28. Then similarly for the second case. Okay. So for the second case, if you want to find, because now V1, V2 values are, I I1, I2 values are there, but we don't know the V1, V2 values. So that's why now we are writing V1, V2 values in terms of I1 and I2. So which means those are the Z parameters, but we know only the Y parameters. Of course, we know again the interrelation between the Z and Y parameters. So by using the interrelation between the Z and Y parameters, we can find the Z parameters and substitute here, right? So then here V1, V2, which is equal. So anyway, as we know already clearly, okay, so Z is equal to 1 by Y. So which means Z is equal to here Y inverse. The same thing that we are applying here. So 0.1 and minus 0.06, 0.14 and 0.2. This is the inverse into here I1, I2 are 20 and 0. So if you multiply these two matrices, then you will get the value of V1, V2. So here the values of V1, V2 are here it is 140.84 and here it is minus 98.59. Right. So these are the values of V1 and V2. Okay. So by using calculator also you can just easily find the matrix multiplication, right? So there is no restriction that we are not allowed to use calculator. So we can use simply the calci so that you can just multiply these two matrices, then you will get the final result. Then in the second case also the same way. Okay, so here V1 and V2, which is equal to 0.1 and minus 0.06 and 0.14 and 0.2 inverse. And now here V1, V2 are 10 and 30, right? So again the same way, if you just multiply these two matrices, then you will get the result answer. So which are V1 and V2. So here the V1 and V2 are 133.8 and again the V2 here it is 56.338. Okay, so now we are going to fill here. So what is V1 here? It is 140.84 and here V2 is minus 98.59. And similarly here it is V1 is equal to 133.8 and here V2 is 56.338. So this is how we can find the solution for the given problem, right? So I hope everybody is clear. The similar way, you can find the other parameters also by using the given set of parameters. So the very important thing here it is this matrix or this table. So by using this table, you can find any kind of two-port network parameters from the given single two-port network parameters. So which means from Z, you can find Y, you can find ABCD, and you can find the H parameters and the vice versa. right? So this is how all about the two-port networks, I mean the interrelation. So in the next class, we will discuss some numerical problems based on the two-port network interconnection, because the interrelation is different and interconnection is different, right? So in the next class, we will discuss some numerical problems based on the two-port networks interconnection, right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.